A circuit board is a special kind of product that is used in all sorts of electronic devices. These electronic devices are highly susceptible to interference during use, which is why it's essential to ensure anti-interference measures are taken during the process of circuit board duplication. What is the purpose of anti-interference? Perhaps some of you are still not entirely clear about this concept. In fact, it refers to ensuring that a system or device does not lose functionality due to external electromagnetic interference, nor does it emit excessive noise interference to the outside, thereby preventing any impact on the normal operation of the circuit board. But from which aspects should anti-interference be addressed during circuit board duplication? Let's analyze this from 3 perspectives. First, during the circuit board duplication process, there are principles to follow when selecting components. At the very least, components should be arranged around the core device for related configuration, and the length of the leads should be minimized. The layout of the components should also be divided into zones, and the position and orientation of the circuit board within the chassis must be properly evaluated. Similarly, the leads of high-frequency components should be kept as short as possible. These points are crucial and are prerequisites for ensuring the success of circuit board duplication. Second, when duplicating circuit boards, reducing noise and preventing electromagnetic interference are both very important aspects. Whenever possible, use 45-degree angles for traces instead of 90-degree angles, and employ series resistors to reduce the transition rate of circuit signal edges. Be sure not to leave unused circuits floating. It's best to avoid this. Also, the clock should be oriented perpendicular to the I/O, as this will significantly reduce susceptibility to interference. Third, circuit board duplication is inherently a form of reverse engineering, so it is essential to consider both the overall layout and the detailed arrangement. Overall layout mainly refers to the size of the circuit board. If the board is too large, the traces become too long, which increases impedance and reduces anti-interference capability, and naturally, the cost also rises. However, making it too small is also problematic, as it can lead to uneven heat dissipation and make adjacent traces more susceptible to interference. How can circuit board duplication achieve interference prevention? The 3 points mentioned above are just a rough introduction. In fact, to truly achieve anti-interference, you need to consider and balance all aspects. Only by reasonably evaluating the pros and cons can you resolve all the concerns you may have.